How airplanes work, the basics you need to know. Airplanes are one of humanity's greatest engineering achievements. They allow us to cross oceans in hours, carry passengers and cargo across the world, and connect people globally. Although airplanes are extremely heavy, sometimes weighing hundreds of tons, they can still fly smoothly through the sky. The secret to flight lies in physics, aerodynamics, engineering, and careful control. Every airplane operates under four key forces: lift, weight, thrust, and drag. Lift is the upward force created mainly by the wings. Weight is the pull of gravity that pushes the aircraft downward. Thrust is the forward force generated by engines or propellers. Drag is air resistance that tries to slow the airplane down. For an aircraft to fly, lift must be greater than weight, and thrust must be stronger than drag. If this balance is lost, the plane cannot take off or remain in the air. The shape of the wing, known as an airfoil, is carefully designed to produce lift. The top of the wing is curved, while the bottom is flatter. As the aircraft moves forward, air flows faster over the curved top and slower underneath. According to Bernoulli's principle, faster air has lower pressure. This creates lower pressure above the wing and higher pressure below it, pushing the wing upward. Another important concept is the angle of attack, the angle between the wing and the airflow. A small increase in this angle can improve lift, but if it becomes too steep, the airplane may stall, a dangerous loss of lift. Airplanes are made of several important parts that work together. The fuselage is the main body of the airplane, containing the cockpit, passengers, and cargo. The wings create lift and often store fuel. Jet engines produce thrust by pulling in air, compressing it, mixing it with fuel, igniting it, and pushing hot air backward at high speed. Most modern aircraft use turbofan engines, which are quieter and more efficient. At the back of the aircraft, the tail section, also called the empennage, includes the vertical stabilizer and horizontal stabilizer. These structures help the airplane stay stable during flight. To steer the airplane, pilots use control surfaces. Ailerons, on the wings, control roll, tilting the plane left or right. Elevators, on the horizontal stabilizer, control pitch, raising or lowering the nose. The rudder, on the vertical stabilizer, controls yaw, turning the aircraft left or right. Inside the cockpit, pilots control these surfaces using a control yoke or joystick and foot pedals. During takeoff, the engines accelerate the airplane along the runway. When lift becomes greater than weight, the pilot gently pulls back on the controls and the aircraft rises.
Readings on cylinder
At cruising
4
altitude,
are fluctuating.
usually 30.000 to 40.000 feet, the air is thinner,
limits,
reducing drag and improving fuel efficiency. Most commercial airplanes then use autopilot, which helps maintain altitude, direction, and speed. However, pilots always monitor the flight and make important decisions, especially during emergencies. Flying also relies on advanced technology. Pilots communicate with air traffic controllers by radio to receive instructions and maintain safe distances between aircraft. GPS and navigation systems constantly track the airplane's position. Weather radar helps detect storms and turbulence, allowing pilots to avoid dangerous conditions. TCAS, Traffic Collision Avoidance System, warns pilots if another plane is too close, helping prevent mid-air accidents. Aviation safety is taken very seriously. Pilots trained for years in airplanes are regularly inspected to meet strict standards. This is why flying is one of the safest ways to travel. Landing is a critical phase of flight. To land, pilots reduce thrust and lower the altitude. Flaps are extended on the wings to generate more lift at slow speeds. And landing gear is deployed. As the airplane approaches the runway, pilots carefully control pitch and speed. Once the wheels touch the ground, spoilers reduce lift and brakes slow the aircraft. Precision and timing are essential during landing. Looking ahead, aviation technology continues to evolve. Engineers are developing electric planes, hydrogen-powered engines, and AI-assisted autopilot systems to reduce pollution and improve efficiency. Drones and unmanned aerial vehicles are being used for delivery, photography, rescue missions, and agriculture. The goal is to create aircraft that are cleaner, faster, and safer than ever before. In conclusion, airplanes may seem mysterious, but they fly thanks to clear scientific principles. The four forces of flight work together. The wings create lift, the engines provide thrust, and pilots control everything with accuracy. Airplanes have changed the world by making it smaller, more connected, and full of possibilities. Today, millions of people fly every day, proof that the sky is no longer the limit, but the beginning of discovery.